So I'm here representing, I'm Anna Chammas, I'm the Director of Innovation, representing not just Miami-Dade County, but the Office of Mayor Daniela Levine Cava. We are very excited she is rolling out, or she has rolled out, a Future Ready initiative that ensures that we have sustainable future for generations to come. That was like just a very short version of what I just tried to say. So anyway, so let's get to the panelists because we've got really interesting conversation to have today. So Esber, he is the Associate Professor of Practice in the Department of Civil, Architectural, and Environmental Engineering for the UM College of Engineering. We also have Roland Samimy, Chief Resilient and Sustainability Officer of the Village of Key Biscayne. Thank you for joining us. I love government partners and municipal partners. We have Brian Haus. He is the Professor and Chair in the Department of Ocean Sciences of the UM Rosenfield School of Marine, Atmospheric, and Earth Science. And then we have Landy, you said? I know it's Landolf, but you told, okay. So Landolf Rhode-Barbarigos, Assistant Professor in the UM College of Engineering. So first things first, we had a wonderful pre-session to talk about, what will we be discussing today, and it was very exciting to meet these gentlemen and the incredible work that they're doing. So I wanted you to take this one moment to introduce yourself, now that I've already said your credentials and what you guys do as a professor at the university or as your role in municipal government, but it would be great to hear about what it is that you do in your work and what your role is and how you feel you can make a real impact in this community. So let's start with Esber. Yeah, you can go in that order.
All right, Will. Can you hear me? It is.
Just give Esber one.
All right, well, good afternoon, everyone. I'm Esber Andiroglu. So I primarily focus on building environmental systems. So within that context, both infrastructure as well as any type of built environment, from water, energy, resource management perspectives, and I typically try to engage my work integrated to the courses I teach, which usually is in the same realm in building environmental systems, sustainability, resilience focus, and same with my research work. And my research focus typically stems from applied research concepts. So I really enjoy looking at a lot of my colleagues' work and really drawing from very serious and impactful fundamental research that produces results, and how I can take that and apply that as a solution, a real problem, real challenge, application type solution through applied research. And the best approach really in carrying that forward is when we showcase it in pilot projects that are in our community, within our reach, and in partnership with our local governments and community partners, whether it's through classes again or applied research projects. So, gentlemen to my left, I'll turn it to you, Ronald, and you and I have partnered in the past in that sense, so that's a perfect example of that synergy.
True that. Thank you, Esber. So currently, as Chief Resilience Officer, my focus is really on how to adapt the community to the challenges that we're facing as a result of changing environmental boundary conditions. And we're really excited about what we're doing right now, and the key for the municipality as a whole, because we're launching a resilient infrastructure and adaptation program that is looking at all of the municipal infrastructure at Key Biscayne and how does it have to be upgraded to address climate change effects and how that relates to intensification of precipitation events, as well as changing boundary conditions such as sea level rise, and how does that affect shoreline dynamics, as well as how does that affect our ability as a low-lying barrier island to move water. So our infrastructure program is really looking to, at its core, adapt and upgrade the stormwater system in order to move larger volumes of water, in order to get rid of the street inundation problems that are extreme presently and only going to be getting worse. And at the same time, since everything is interconnected, we got to then look at what sort of roadway improvements do we make as a complement to the upgrade of the stormwater system? What do we do with our rights of way? What do we do then when we shift from a gravity-driven system to a pump system? And how do you stabilize your power supply? Because your system's only going to work as well as your pumps operate, and so on and so on. So then, you know, it's like, okay, well then maybe we got to underground the electrical utility. But if you underground the electrical utility, then you got to underground the telecom. So then you got to work with Comcast and AT&T. And then if you're in the ground, you got to look at, well, what's the age of the water lines and the sewer lines, and how do we coordinate with Miami-Dade Water and Sewer Department's capital improvement program such that we can adopt this one dig once philosophy, this dig once approach, because we're such a small island that we can't constantly be going back and ripping up the streets to make an infrastructure upgrade. We'll be lynched, first off, and it's just cost-effectively a terrible way to go. So it makes it very complicated as to how do you coordinate all of these moving parts, but that's what we're endeavoring to do, and at the same time coordinate with the Army Corps relative to what we're trying to do on the ocean side for stabilizing the shoreline from now through the next 50 years, but then also what do we do on the bay side, because at the end of the day we are an island, and the Corps is always looking for a whole-of-system solution. So it's not just enough to make a federal investment on the ocean side, because the benefits area is threatened from the bay side, so therefore then you got to look at the bay side and integrate a bay side solution with an ocean side solution. So as Chief Resilience Officer, I'm supposed to be the puppet master coordinating all this with the manager and the directors of Building, Zoning, and Planning, and the Public Works Director, and Capital Improvements Director, and so on and so forth. That's my challenge as a former nutrient biogeochemist and Esber scientist, which is what connects me scientifically and technically to Esber and to Brian. So that's my story, that's what I'm sticking with.
That's a good story.
Okay, thank you for the introduction there to kind of things we're doing. So I'm involved, my training is as a coastal engineer, and I've been focused for my career on experimental observations of waves and currents. And since coming to Miami in 1993, so right after Andrew, I've been involved in research on high wind conditions and really energetic conditions. I was fortunate enough to be able to have been involved in the building of a new facility at the University of Miami's Rosenstiel School where we could simulate Category 5 conditions in the laboratory and learn a lot about what happens at the air-sea interface in extreme conditions. We've used that a lot for forecasting, trying to make forecasting improvements, to help the models to say better what the hurricane intensity will be sooner, so we all have an opportunity to plan evacuations, etc., in a better way. Better understanding what the storm is going to, what is going to be happening. Now, of course, as being in South Florida under the regime of sea level rise and looking at the going forward and the threats our community faces, it's clear that we really have to plan ahead for our future and can't just be reactive to the storm coming 2 days from now and worrying about it then. So fortunately through the University of Miami, there was a program established, ULINK, by Andiroglu, who to bring multidisciplinary teams together to look at societally important problems like how we live in South Florida under sea level rise, under the threat of tropical systems, and began to work with some of these guys here. Hope to be working more closely with Roland in the future, and to develop approaches to bring both engineers, scientists together, and biologists. They're scientists too, but physical scientists like myself, hydrodynamicists like myself, biologists like communications, architecture, all these disciplines together to look at how we might solve problems. And one of the things we're working on is hybrid solutions to provide protection for coastal resilience. Now, at the Smart Cities Conference, we're all concerned about data. My job, my focus has been for my whole career on how we're generating data, looking at data. So I'm at the input of all this. And so I don't know if some of you have had a chance to see the kind of structures we're putting in off of Miami Beach now. We have put in and are planning to put in the future to help provide a basis for corals or mangrove growth, protecting shorelines. But these can also be very important places to put sensors to give the kind of information that we need to better understand what's happening offshore, just offshore of Miami and at our coastlines. Because that's a key part of all this. If we're going to be using AI and all this, it all requires data, and there's a real paucity of data available in the coastal ocean right off of Miami. You wouldn't believe there isn't even a wave measurement off of Miami that's regularly reported. We've lost our Seaman Tower, the Fowey Rocks is not reported for months. So this is just, in a major city in the U.S. on the coastline. We don't have enough information. We're working to make that better, and some of these things can be used to help that.
Good afternoon, everyone. My name is Landolf. I'm an assistant professor at the College of Engineering. I'm a structural engineer by training and maybe an architect by heart. I work with structural form, trying to design structures that will basically provide coastal protection, but at the same time habitat. When we had the chance to work, so when I first arrived at UM, we just had this facility that Brian just mentioned, Sustain, being inaugurated. So one of the first things I thought is I need to get in and I need to put models in so that we can generate that data and see the effect of those structures and models on waves. So we had the chance with Brian and the team to collaborate on this, and now we're working on what we call green-gray infrastructure. But this is quite unique because now we have to rethink the way we design structures. So it's not only about basically dissipating the wave, but it's also about hosting a living organism inside that structure. So we have to think about the material we use, we have to think about how we install them, so sustainable practices, designs, and so on. So it takes a while until, but we have the chance and the responsibility also to work with the communities here and to develop, to go from the development of idea all the way to implementation and pilots. And that's kind of my role there, and I see myself as a student of many of those colleagues here, but also at the same time somebody who would challenge also the local, let's say, communities and the regulatory framework to develop and push forward, because this will require, the new solutions will require new platforms. So that's what I see myself in.
I love that. That collaboration is really important. You'll hear that from our mayor later in about, I guess, half an hour. She's very passionate about that, and that collaboration amongst other governments and municipalities is critical. And coming up with ways that we can create an alliance to do that is, and then have your expertise really school us on how to get this right? So I do want to cue a video that was going to be played that these gentlemen provided so that you guys can see a little bit, small snippet, it's a couple of minutes, just a small snippet on some incredible work that they're doing. really exciting and incredible, right? And that's just one small project that this team is working on to really make an impact and to secure the future of, our coastal, coastline. So we're going to transition now to really talk and focus a little bit on specifically what we're talking about here today, which is smart city efforts and the data that they're going to work on to collect and how they believe that could really make a mark in protecting our coastline. So, first and foremost, actually, Roland. So, since you did talk and you are a municipality and you are the island that is surrounded by what could potentially be stormwater management needs, taking care of our coastal health, and really looking at that. First and foremost, when you think about how data can help in policy-making decisions and the decisions that are going to help determine how to protect that area and the region that you're in charge of, and how then you can further use that as a model that we can then, for other governments within Miami-Dade County, that we can share that information and that data, especially and specifically like with Miami Beach and other coastal cities.
Sure. So I actually want to tie specifically to what Brian's doing because in truth, working with the Corps, they've already done analysis, a feasibility study of the oceanside shoreline protection approach that might be most useful to Key Biscayne. However, it's a little bit of a complicated story in the sense that there is an approach, such as Brian's, for wave attenuation as it relates to shoreline recession or not, and which relates to the frequency at which then the Corps needs to re-nourish our beach, because the fact of the matter is that's always going to be part of the solution. And so the complication arises in the sense that an approach like this might have been taken off the table at one point because their models indicate that damages are driven by inundation as opposed to erosion in wave effects. However, the beach renourishment quote, the beach renourishment element could be extended and benefit the Corps in that if they don't have to do it as often, then that's a savings to the federal government. So whilst they initially have, say, 16 or 18 or 20 months between nourishments, if we were to do wave attenuation, maybe the erosional effects could be reduced, extending the time between nourishments, saving the federal government on beach renourishments. However, they don't necessarily feel like that's part of the equation because the benefit-cost ratios would suggest that it's not worth the investment. So there's this need to have the data sets that are collected by Brian that document, quantify the benefits of wave attenuation on shoreline recession or not, that then can be utilized as a justification for, well, you know what? It might be premature to take this approach off the table because your beach FX modeling effort doesn't really accommodate that approach. And so without this data, you don't really have the information to then go back to the Corps and say, you know what, this actually really should be considered, we shouldn't be taking it off the table, and then you move on from there to all the other complicating issues related to having to evolve, the county approach to impacts of this on seagrasses and then remediation, and how do you then balance that out with the the ecological service benefits that you get from essentially creating an artificial reef. So yeah, you have seagrass impacts, but then you have an artificial reef that you didn't have before. But the regulations that were put in place to protect the environment in the first place, which was great and needed, need to evolve so that we can actually do the innovative adaptations to climate change and sea level rise and so on and so forth. So that's kind of where we're at relative to that.
That's so interesting. I'm wondering if others here, if you are part of a government or part of a resilience program within a government, that's very interesting insight. So as a team, our UM panelists, There's a lot of pride in looking at that, huh? And then to hear what Roland can do with that data is pretty impactful. So what prompted you to, want to move in that direction, and how do you see that as, leveraging this, this data to help governments develop that type of policy or revision in policy?
Again, I think the most important thing here is that we went from an idea to a laboratory data set to actually a pilot. And also there are some of our colleagues like Sonia back there and Jodica that they focused on the impacts and the data that how would this translate into basically the community. So getting that data set is critical for us. We also have USGS coming to make some measurements, because this is a unique experiment where we have basically human-made structures. There's human-made structures, a series of them, and then basically we can see how they protect, and then once we transplant the corals from our nursery, we're going to make the same measurements, and we're going to see basically the added value of having corals on a structure. This is quite unique because when we're on the field, the measurements that we make include directly the substrate and the coral skeletons. And here is quite unique because you have that data set without and with. And that data set can really shift the conversation about how we use coral restoration for shoreline protection. So it kind of provides people that are interested into pushing forward that discussion and enables them. And I think that this is very important for us.
I kind of want to take us back, from my perspective, about 4 or 5 years back, when Brian mentioned U-Link initiative that was, started at the University of Miami. And I was one of the first participants in the U-Link teams, and our team was, our project was surveying coastal defense systems in South Florida to better understand how they performed and how they fit the needs of the regional communities. And one thing we discovered through that 1-year-long investigation, and we documented and published it, was the fact that the same solutions did not fit at every community, every site, and the same because the challenges were quite different. There, as was noted, some regions where wave mitigation was, energy mitigation was key. Other areas were, beach nourishment. Other areas were water quality. And there was a myriad of solutions that we could introduce, but then acceptance from the community was the challenge. People were discussing views. They were suggesting mangroves, but what happens to our views? Or how much space do you need to deliver this solution? So at the end of the day, today, we understand that the data sets that we are gathering through these pilot projects become instrumental for us to develop the prescriptive solutions that are site-specific, and at the same time, having the data and the pilot projects in a community really makes it happen. Because every time you present these ideas to a community, the stakeholders, they always ask, how do I know that it's going to work? So having the data sets and pilot projects performing simplifies the process for legislation, scaling up, and taking it to the next level.
Okay, so in the meeting that I had with these gentlemen, also got to explore some of this work that Brian's doing, and I started delving in, and I just think it's so incredible, the facility and everything that you have. And I don't know how much people know beyond this work, all of the work that you're doing. Are there a couple of projects that you'd like to highlight that are exciting? Just the facility itself, I can't wait to go visit. I invited myself, by the way, because it's just so impressive.
Thanks, Anna. I really appreciate that. There's a lot of efforts going on, and I think that this project here is one of the key linchpins for this, is this work on developing improved methods for coastal resilience. And this all gets into, and there's other work that we're doing related to coastal wind fields, and in particular in high winds and storms. It all gets into what Ben is talking about earlier about hyperlocal impacts. And as we get all the data that is coming in, I think that it feeds into a lot of things. This is where a lot of different directions are going with ensuring coastal properties in hurricane-prone regions that are exposed to sea level rise and storm surge. The insurers need to know which properties are good risks and how you can discount people that do the right things for protecting their property. So that gets into these really local stuff like block level, local information. And all of this requires data. And the key thing that we're doing in the lab is we can bring a hurricane into the lab so we can get good data on what happens at where
That is so cool.
where the air and the water meet and where they run into structures. And that's, Landolf and I have a project with NIST that's really working specifically at that, how you look at the combined loading of winds, waves, and storm surge on structures. And that's critical for developing improved building codes because the building codes are based on or zero data really about what actually happens in those conditions. In a Category 5 landfall and hurricane, like in Hurricane Ian we just saw, that incredible damage. There's not many sensors that survive that. And you'd have to be in the wrong place at the wrong time to get that data, right? So we're doing that. I think this is a real benefit is providing the data that can help make the models better in the laboratory. And that's really key to all this, all those components of it together. And then the project that we have now with our with DARPA, that is bringing all these pieces together to try to do that, to bring those pieces together and put it out there for as a bit larger scale than this. The next step forward is to put these types of systems out to provide resilience for government properties and then for public infrastructure as well.
Thank you for that. So I think we have about 10-15 minutes, and I feel like we could talk for hours, so I can't wait to know more, and I am honored to have met you guys, you gentlemen. So there are a couple of little extra questions I wanted to ask before. And this one's kind of like a positive but negative. So what do you see the risks of failing to adequately cooperate across the region when it comes to rolling out this type of smart city work that you're working on? And I want to first direct that to Roland, since I know that, as both of us representing government, it's so important that we all work together. And how do you see that we are collaborating and the impact that could have on the region?
Sure. Well, I would start with this corny line, which is that water knows no boundary. Okay. So it forces you to have to look at things in an integrated manner, because water connects it all as the common thread. But it also forces you to work with your stakeholders and partner agencies in a very collaborative sort of way in order to cost effectively and from a solution point of view, effectively implement strategies that may be innovative or traditional or whatnot. We've had a very good relationship with the county and with agencies like the Corps, and it is literally the strength of those relationships that enable us to be able to implement big things and get on that crazy train and think really big. Like for instance, we were just having the Back Bay charrettes with the county and the Corps on the Atlantic solution and whatnot. Well, so that's a crazy train that you can consider getting on and trying to implement if you're all working together in like a common purpose. Right. And for us, we are now going to be getting onto that crazy train with the Corps on our Back Bay analysis, but the two really have to come together because that Atlantic solution has like a Rickenbacker Causeway component, but then the Rickenbacker Causeway component can then feed into what kind of really visionary approach you try and do for a Back Bay solution to Key Biscayne, which then ties into the Oceanside solution. So it's like you absolutely have to work together in a cooperative, collaborative manner in order to do the bold things that are needed for this region to elevate it to where it needs to be for the next 30, 40 years, and then the folks that will be sitting here 30 years from now can then do the recalculation and the recalibration of what the investments need to be, because what we set in motion and put in place are like maybe no longer adequate because things are still changing, you know. So that's kind of where I'm coming from on that.
Well, that is quite visionary, and it's so incredible that the four of you work together collaboratively to get this done. And we at the county are very grateful. So I want to close it out, and I would like for each of you to briefly describe the most exciting smart city tech or policy that will be introduced that will impact coastal resilience. So it's kind of like a little bit of a speed round. So let's start with Esber. You want to repeat that?
That's an interesting question, and many ways we can approach it. But I'm going to first say, to kind of follow up from where Roland left off, is how we communicate really among each other and with our stakeholders, and how we understand the barriers and resources and tech innovations for integration and deployment is essential. So I think we need to definitely work on that, and I think heading into disciplinary collaboration and research and these type of workshops and symposiums is essential. And because once we cross that, it's interesting, Landolf and I were on a call this morning with another local regional community partners on a similar solution applications. And we discussed for a while what are some of the barriers and challenges, and we have all these great tech innovations, we can gather data, but is it easy to implement? What's in our way for implementation? And collectively we concluded that we shouldn't look at anything as a barrier, but rather how can we communicate through and win? And whether it's someone who feels like a barrier or a system or policy, how can we overcome or better express that? So I think moving forward, that's the direction we would need to take. But as far as tech innovations go, especially in context of smart cities or data science, I mean, it's huge. It's a huge spectrum. I'm passionately engaged on a different topic, as we speak, which speaks to water efficiency in premise plumbing systems in built environment, and understanding how water is used across the globe by different stakeholders is a huge topic. And the only place we have to turn is data and tech innovations that can deliver that data so we can find those type solutions.
Yes.
So from a municipal point of view, I'd say since we're making hundreds of millions of dollar investment in our stormwater system infrastructure and bring it up to where it needs to be, the question then becomes, is it a dumb system or is it a smart system? And are we actually monitoring its performance in order to determine A, how it's working now, and quantitatively be able to explain to people how it's working? And obviously it can see the benefit because it's like, all right, the street's dry or it's not, great. But from an operations and maintenance point of view, is it a smart system in that can we quantitatively determine how well it's operating and how the effectiveness of the system may be changing over time as it ages or as the boundary conditions change? And then does having that access to that operational data give us the ability to run the system better or improve the system as it needs to be improved over time as its performance starts dropping off? So that's something that we're considering as a municipality, just in terms of the function of the core of the system, which is stormwater and how's it doing relative to effectively moving water off the streets. So we're looking at that, and then obviously we have a seawall ordinance that we're developing as that relates to shoreline protection, which then drives policies as to what you do where, and then that connects up to the core and what they're trying to do relative to shoreline protection, and also our stormwater system, what we do with outfalls, that affect seawalls, and so on and so forth. So that's what we're also looking at. Not as tech-oriented, but policy-oriented.
It's important.
Yeah, and I'd like to follow up on something Roland said earlier. You know, the water is what connects us all, and in some of the early core charrettes on the first Back Bay study, I brought that up and said, you know, we really should be considering water quality has to be on the table for all these projects, or considered, and I was told that that was outside the scope. And I was stunned because, as many of you, most of you may realize, you know, the Everglades restoration failed because of water quality issues. You know, $25 billion Everglades project was built as a flood control project and failed because of water quality issues, costing now $25 billion or something like that to partially fix. So we need to consider the implications of what we do in a holistic way, and water is what connects it. And I think one of the key smart city type developments is the development of cheaper or more capable sensors that can measure water quality in real time and report that wirelessly. And we need to get this information. We have a lack of information for what I usually do, wave measurements and wind measurements and tide levels and surge and all this stuff that can tell us about the hyperlocality. But we need to supplement that with information on nutrients, water quality, all this stuff. Get it up to the central, you know, modeling and all that, so we can have that information available. Because otherwise, as you just said, we will be reactive to things that are already too late to react.
Last but not least, Landolf.
Yeah, maybe I'll change a little bit the tone, because once we get all the data, what makes a structure smart or a city smart is how we react. And I think that this is the other side. So once we get the measurements with the sensors, and once we have all this together, we need to know how we're going to react. And I think it's all about the people. So we have to make sure that, I mean, as we build smart cities, we're also smart citizens. And we have a smart leadership. And actually, that for me means that we are agile, that we know what is the right thing to do. And when we don't know, we ask the question. And I think this is very important. So I applaud again the platforms that the communities provide, and basically you at the county and everybody around us is giving us, because that data can really, it's not only about the data set, but it's also what you do with the data set. And that is a critical part.
Yeah, it's echoing what Roland was talking about. Instead of dumb data, let's make it smart data and do something about it. So I want to thank you all very much. I saw that the mayor walked in, one of my favorite people on the planet, a planet warrior, a water warrior. I don't know if someone's supposed to introduce her or if we're ushering her in, but I want to thank you all so much for being